Now let's have a look at the firewall virtualization technology. So which kind of virtualized concept that we used in the firewall? I will share with you the information regarding the virtual router, virtual switch, virtual system, and also the simple switch. First of all is the virtual router. So virtual router, as I mentioned during the HCSA course, so virtual router is virtually a router, virtually acts as a router. So different virtual router have their own independent routing table. The trust VR, which is the default virtual router that we predefined in the system, we support to create multiple virtual routers. The number of the virtual routers is varied based on different model of the hardware capacity. The independent transmission of the multiple VR. The reason why we are using multiple VR is for the independent traffic transmission. By using those multiple VRs, we can even support the overlapping IP address segments. Those data that transmitted through these different virtual routers will be handled independently without affecting each other. So that is the purpose of the virtual router. So we can manage the traffic independently without overlapping. Here's the multiple VR configurations example. So first of all, you need to go into the virtual router to create a new virtual router, and then you can create the zones that belongs to the virtual routers. And then you can configure the interface that need to be bound to the specific zone. Another scenario, if you have multiple virtual router, you can also do the traffic forwarding that cross these multiple VRs. As you can see this diagram, we have trust VR and we have a new VR1. We can forward the traffic that pass through the trust VR and also the VR1. So that is another scenario for the traffic transmission cross VR. Here's just the example. You guys just take this as a reference. So after the virtual router, the second one will be the virtual switch. If the device that deployed in layer 2, we need to use a virtual router, which is the virtual switch, which is the virtualized switch that we used to transmit the traffic through layer 2. By default, we will ship all the traffic. We will forward all the traffic through the default virtual switch, which is vSwitch 1. Every time you create a new virtual switch, we will create a corresponding virtual switch interface, as I mentioned. The virtual switch interface will be created automatically for each of the vSwitch. So you can bind the interface to vSwitch, and then this interface needs to be bound to the specific security zone. So vSwitch will act as the layer 2 forwarding zone. And each of the virtual switch has their own independent MAC address table. So in this case, we can use the virtual switch to do the VLAN transition in transparent mode. This is the example for the vSwitch and also the VLAN, which are working in layer 2. You need to bind this sub interface that's supported for different VLAN to the layer 2 zone, and all the layer 2 zone need to be bound to the virtual switch, And next one will be the virtual system. The virtual system is used to divide the physical interface resources into multiple logical virtual firewalls to do the micro segmentation. So each of the VCs has their own system resources and perform most of the firewall functions like AVR, like IPS, and working as the complete independent firewall. And the VCs will not communicate directly with each other because they are separate. Normally we use VCs to do micro segmentation, to do the independent management for the specific service or for the specific applications or users. The VCs has these following characters. First of all, each of the VCs will have their own administrator. Each of the VCs has the independent virtual router, the zones, the address book, the service book. And each of the VCs has the independent physical and logical interface. And they also have the independent policy rules. You are able to access to any of the VCs through the root VCs. So here is the comparison between the root VCs and the non-root VCs. The firewall device, by default, will act as the root VCs. So the root VCs, which cannot be deleted because it's the entire firewall system. You can create or delete for any non-root VCs through the root VCs after you installing the VCs license. So you need the VCs license to support the VCs function and also determine how many VCs you can create it for a dedicated model. And after the license install, you need to reboot the device to take it effect. And when you're creating a non-root VCs, all these corresponding objects will be added simultaneously. For example, the administrator with the overall permission, which is the admin for the VCs, and also the password. And a default vRouter named the VCs, following with the VCs name, will be added as well. When you're deleting a non-root VCs, all those objects, all the logs that belongs to these VCs will be deleted. The root VCs contains the default vSwitch, which is the vSwitch 1. And for the non-root VCs, there's no default vSwitch. So you need to manually create a new vSwitch in the non-root VCs. And administrator in different VCs, they are independent from each other. So the root VCs admin, which is the admin for the whole device system, is the root administrator and also the administrator in non-root VCs. So we have the root administrator for the root VCs, and also you have dedicated administrator for each of the non-root VCs. The non-root administrator created by the root administrator. And after logging to the root VCs, the root administrator can switch to the non-root VCs and also have the configuration privilege for all the non-root VCs because they are root VCs. And non-root administrator can enter to their corresponding non-root VCs after the successful logging by using the non-root administrator login. But the non-root administrator cannot switch to the root VCs because has no privilege. And each administrator name will be unique in the VCs. And also some VCs sharing for the shared object and also dedicated object. So the vRouter, vSwitch, zone, and the interface that used in each of the VCs have two properties, which is shared and also dedicated. For the dedicated object, so that means this object belongs to the certain VCs, cannot be used by others. Both of the root VCs and non-root VCs can have the dedicated objects. And the second part will be the shared object. The shared object will be shared by the multiple virtual systems. The shared object can only belong to the root VCs and not be able to changed by the root, can only be configured in the root VCs, cannot be changed by the non-root. So the non-root VCs can reference or can call this shared object. And all this shared object must be unique in the whole system. So when sharing the object, it will share the vRouter first, and then the zone that bound to the vRouter, that bound to this virtual router. Here is the VCS configuration example, which is cross VCS forwarding. As I mentioned, for the firewall itself acts as the root VCS. So by default, all these resources belongs to the root VCS. And you can create for some non-root VCs, to manage for the specific users or applications or service. So we use the VCS A and the VCS B to manage for different department 1 and department 2. So department 1 is managed by the VCS A, department 2 is managed by VCS B. 0/0 is the dedicated interface that we assigned for VCS A, and Ethernet 01 is the dedicated interface we assigned for VCS B. And 0/3, which is the egress interface in the root VCS, is the shared interface for both VCS A and VCS B to access to internet. So we have some shared interface and we have some dedicated interface. Here is the configuration for the root VCS. So first of all, you can create non-root VCS under the root VCS by using the VCS command. And then you need to configure the interface root and also other through the root VCS. And then you can configure for the shared VR and shared zone, and assign the dedicated interface to different VCS So this is the dedicated interface to VSys A and dedicated interface to VSys B. And for the non-root VSys, you can create for their own interface and also policy and root. So that is the configuration in non-root VSys. The simple switch is used based on the requirement from some specific customer. In some case, they need to allow the communication between the VSys, which is the cross-VSys traffic forwarding. In this case, we need to add a simple virtual switch to allow the traffic forwarding across different VSys. So the system introduced the simple switch, which is the special virtual switch, allow the MAC address learning and forward the known unicast packet of flooding the traffic. Here's the configuration. So you need to enable this cross-VSys traffic forwarding, and create the simple switch, the simple virtual switch. And here is the configuration for each of the virtual switch that route the traffic that through the simple switch. So that is the virtualized